image formation due to plane mirror. Let me take this as a plane mirror. I'll keep object. Let me keep an object here. Oh. Or object in sense, let that be flower. There's an object. Okay, no. So what is the method here? How to study the reflection concept here? There's a luminous object, so it will send the rays. It will make the rays either the real object. What is the condition of real object? The rays will be, incident rays will diverge from a point. The point of divergence should be the real object. So I'll send a rays here. Then after reflection, this is very, very, very important, a fundamental. So after reflection, what we see is like, let me indicate the image. The image, let me indicate by other color so that it will be, or also I will take the same red color. This is a real object. And what I get is, this is the image. Now the reflected rays, let me show by other color. Now you can ask questions, sir, how you are drawing that ray. So based on the laws of reflection, I'm showing that reflected rays. Okay, this will be the incident ray. And this is a reflected ray. So from the laws of reflection, this will be the angle of incidence, say theta 1, theta 1. This will be theta 1. This will be angle of reflection. Theta 2. This will be theta 2. This will be theta 2. Angle of incidence should be called angle of reflection. Angle of incidence should be called angle of reflection. So from the similar triangle, so this is O, the object, real object O. This is called as I. Let this be M1. This point where the second ray strike the mirror, let it be M2. Let me take this is P. So this angle will be theta 1. This angle will be theta 2. So the triangles will be similar. So if you look at the triangle, MPO and MPI are similar triangles. And because of that, what I can write, PO, or yeah, books they preferred M1, no? This is, in the books open they took M. Okay, let me write PO only. So therefore what we can write, PO is equal to PI. What is PO? PO will become object distance. What is PI? Will become image distance. Object distance, this image distance. So for a plane mirror, what will happen? The object distance is equal to image distance. So this angle, sir, now you can ask question like, sir, on what basis you are writing this theta 1? Look at this. If this angle is theta 1, this should be theta 1. If this angle is theta 2, this should be theta 2. Look at the geometry. Theta 1 is angle of incidence of the ray at M1. Theta 2 is angle of incidence of the ray at M2. So if I take this theta 2 is angle of incidence, then this angle should be theta 2. If this angle is theta 2, then this should be theta 2 because the ray is produced back here. From this, what I can conclude that from these two triangles as the similar and M1P is common. So therefore, the PO must be equal to PI. So therefore, for mirror, plane mirror, the object distance will become equal to the image distance. This is very important. I'm saying not displacement, distance. If you stand at a distance of 1 meter, or say like a 2 meter, where your image will be in the plane mirror, 1 meter. At the same distance, 2 meters. Suppose you are at a distance of 2 meters from plane mirror. Your image will be at a distance of 2 meters. Okay, let's come for this one. What is the nature of image? These are the reflected rays. The reflected rays are diverging from a point. So therefore, this image must be virtual. I'm going to write now. So what are these? These are reflected rays. These are incident. Like this, we can trace out an image. Say we should take help of the geometry here, the basic geometry. Now you can ask questions of why you took 2 rays. You can take any number of rays. I think 2 rays will be sufficient. How do we measure object and image distance perpendicular to plane mirror? Any condition? U and V are measured perpendicular to surface of a plane mirror. No. So like, can I do by another method? Yes, if you want, you can do by another method. Suppose if I, instead of this is a mirror. Let me keep an object. And the corresponding image will be here. Some other color. Oh, yeah. This will be corresponding image. Then can we trace out the rays by any other method? The incident rays, let me take this one. So one ray like this. After reflection, okay, similarly, just make observation. I'll construct the ray diagram. You can also construct a ray diagram like this. It's not that the 2 rays should be above the certain horizontal line. So there's a ray 1, there's a ray 2. Need not be symmetric, even this angle. Angle of incidence theta 1, theta. Or so like let me call theta. This angle will be theta. If this angle is alpha, if the angle of incidence is alpha, this will be alpha. Now whatever this angle will be alpha. This angle will be theta. Now also you calculate PO equal to PI. To construct to trace out image, what happens? Minimum we need to reflect two reflected rays. You can send n number of rays. So 2 rays will be sufficient to construct a to trace out an image formation. Why this image should be virtual? Because the image is formed due to diverging reflected rays, and the point of divergence should be position of the virtual image. And why this object is real? Because the incident rays are diverging from a point. The point of divergence should be a real object. So what is the plane mirror? For real object, it will form a virtual image. For real object, it forms a virtual image. And what is the condition? The object distance must be equal to image distance. There's a one very, very fundamental thing that one. And all object and image distance are measured normal to the surface of a plane mirror. So what is the conclusion? A plane mirror. I'll show both the situations. A plane mirror forms virtual image for real object. Similarly, let's take other situation. For virtual object, for real object, virtual image. For virtual object, what is